Hello fellow problem solvers. So this is a update video that I haven't done since I came to Brown. So let's do it now. So currently I'm on Schwarzman College in Tsinghua campus. I'm a Schwarzman Scholar. But let's explore Tsinghua and I'll get you all up to speed on what's happening and what it is that I'm trying to do now. I did not expect it to be raining while I'm making this video, but we have to do with what we have to make do with what we have. So after Brown, I started a master's program and a PhD, and then later a PhD at the University of Maryland College Park. And I was graduate fellow at the National Cancer Institute in the Cancer Data Science Lab. Now, that had its fun moments. But I left that after a year and a half to prepare for this program, Schwarzman Scholars, which, even if you like mathematics, and if you Google the program, you'll see what it's about, global young leaders for the future, trying to understand China. But even if you're just like math oriented, you should definitely think about introducing this into your education in some way, shape, or form. Because I've got to say, it's just been an incredibly cool experience overall. Being in the best university in China, maybe even in Asia by some rankings, and having classes with a very diverse set of people. So definitely put it on your radar. And the thing I've been also doing while at Schwarzman is learning a bit about global affairs, international relations, but also was building the next iteration of Shef Scholars, which is going to be launched very soon. And let me talk to you a bit about that now. So the idea is that we launch a competitive math school, Shef Scholars, because it becomes a competitive math school that basically helps you, train you from zero to the IMO. And I've decided I've spent time here researching what to do, what are the different steps of development that I want to take with this. And the idea is that what we'll do is we will first launch this competitive math school. The first round of applications will just be open to people that know it through the YouTube channel or the word of mouth. We're gonna cap classes at 25 people. We're gonna go in 2 different time zones, right? So we're going to be one that is, for say Central European time, that's going to be early in the morning and then later in the afternoon, such that we can have people apply who are both in the Americas, in Asia, and that are in Europe. So there's a good time for everybody. And then the idea is that what we do is we go over once a week. We have 2 lessons a week, an hour each. Outside of that, you have your homeworks. Every month there's an exam, a test to test your knowledge to keep you on track. And we go over the test, we go over general problem solving principles. And on top of all of that, what we also want to be doing is have some lectures on university math, introduce what you do in uni. And even on top of that, I'm thinking of even getting some of my friends that have done competitive math, that have done different things, 10 years now after competitions, or 5 years after competitions. And what are they doing? What do they decide to do with their life? Look at the beautiful campus. So what do they decide to do with their life? And the idea is talk a bit about, future career trajectories that you can take after finishing with competitive math. And I am now trying to, on top of all of this, on top of building this program, building a whole lecture from zero to IMO, okay, competitive math path, basically. What I'm also thinking of trying to do is, on top of that, trying to build the best sort of resource for competitive math, a thing to help track you on your problem solving journey, and make some website, app, whatever, to have all your competitive math needs in one place, from zero to IMO. And the big sort of value add, the big idea is structured learning. And there's a bunch of different ideas I have about this. If you have any ideas, if you'd like to give feedback on this, or any things that you wish you have in your competitive math journey that's missing, sort of asking yourself what's stopping you, by all means, let us know in the comments below or shoot an email. And yes, that's the big idea. Now, what have I been doing in Schwarzman? Right, so I'm in Zhongguo, China, and it's been a wonderful experience. Like being on the best, a beautiful campus here, and learning a bit about China, how China works, and also meeting an incredible cohort of about 140-ish people, and getting wide exposure to the alumni community as well. The whole point behind the program is to get people who are now young, who will in the future be leaders in some way, shape, or form, whether in politics, policy, business, or science, other areas. It's a very cool, diverse set of people that you become friends with a couple of them. So later down the line, you can make collaborations with some of them in your area of interest. So it's been an amazing thing for me. On top of the programming, what I've been able to do is start another YouTube channel, actually a podcast, something that I found interesting, which is on politics in general, called the Politically Active Podcast. The idea being interview people that have been politically involved in some way, shape, or form, with academia, policy, and interview them about their lives, how they got into politics, the lessons learned, leadership case studies, and maybe some advice for people who want to get involved in their position, some advice for the future. That's the general idea of these conversations. And I've gotten the privilege to talk to a bunch of very, very, very interesting people. Now also, I'd like to talk a bit about the Schwarzman program and what I've actually done in here, which is outside of meeting very interesting people, getting to know China, learning a bit of Chinese. I have a Chinese name now, Shangquan. I have a character right here for that. And it's also been very interesting. The thing they helped us with was this venture creation lab, where we are trying to create our own venture and pitch it at the end. But it was 5 months of research, thinking about different ways to solve a problem, and how do you create a solution that's unique, that doesn't exist in the market, yada yada yada. And that's what I've been working on since October of 24. And now things are coming together where I'm thinking of, okay, let's now create this, the first phase is creating this competitive math school, right? So every weekend, what we're going to be doing is just solving math problems, learning techniques, and I've got a bunch of my friends who've been doing competitive math as well at some points. I've got a bunch of them to come and teach as well, and I think it's gonna be great. But there's also ideas for the future. So what are the next steps? So after we are building the school, now we're just we've made a bunch of lectures, we're adding some more. We are also trying to add on top of these lectures, trying to add more specifics. How do you give a lecture? So, what do you need to do to prepare for a lecture, which is on the back end, trying to say more specifically, how do you reach out, when do you reach out for students, to ask them questions? What do you do if students say X, students sometimes say Y? We're trying to build that so we can create the best a training material basically for competitive mathematics. And also I think the big thing that having a school that you go to for competitive math and a peer group that you're solving problems with is accountability, right? That and a sense of competitiveness, right? So if you're doing competitive math, you have some level of competitiveness, and where you're from, in your immediate surrounding, you might have maybe one or two people that are very interested in like competitive math and like very ambitious. And sure, that can be helpful. Absolutely, it's better than none. But the idea is, okay, what happens when you have more? What happens when you have more people who are interested in this competitive math thing that you're interested in? They can push you forward. When you have weekly problem sets due, you are more motivated to keep learning, and you know that also the things that you're learning are going to be useful because they are true and tried, like they've been done by other math competitors, and you know that once you get through a certain number of these classes and once you put in the work, you're going to have developed these problem solving skills for competitive mathematics. And the idea is also on top of that, you have this idea of, okay, what is university math going to look like? So say we do a lecture on cryptography, or we do a lecture on real analysis that's open to all groups. Now the whole idea will be, again, to have groups like beginner, apprentice, machine, chef, a test beforehand, an application. And yeah, I think it's going to then we're going to maybe interview some people, right? Because we're going to be limited in the number of people we can take, right? We're going to limit this to 25 students per class. And we're going to first like just launch it on the YouTube channel, and then we're going to like very much advertise it to like schools, the wider community of competitive mathematicians or people doing competitive math. And it's going to be like, we're now building a syllabus and also our roadmap from zero to the IMO, which you can also look at if you want to, just if you're thinking about like what things should I study, we'll have a roadmap as well for that. And of course these roadmaps are rough, but they're like roughly ordered at what points you want to take a look at these things. Now for the competitive math thing, like I'll also offer another package, like the premium package as well. There's gonna be two packages, one is just the classes where you're getting tested as well, and I get homeworks, and you have this peer community. But that's like one version, right? And the other version is the premium version, where every week you meet up with a mentor at least once, sometimes twice. And on top of that, you also get a chance. You also have like once a month, I make an hour-long lecture for you. So it's going to like be the premium offering that we're gonna have in this program. And I don't know, like I'm very excited about both, in the sense that the classes there are for, if you just like are very, very self-motivated, then you just, do the classes. But if you want more personalized feedback, more personalized problem sets, more personalized lectures, like on top of everything, if you think there's something else that's missing, or if you would like to have an added value, or if you'd like, more accountability, then there's this option as well. Now, another very, very important part of our teaching is the Shef Methodology, is what we're calling it. And it's what is the Shef Methodology? So the idea is basically, when you're teaching some theory, for example, or anything, your focus isn't just on presenting a solution, or presenting, hey, this is what the theory is. Like, say, Viera's rules. Well, if you have an ax squared plus bx plus c is equal to 0, then x1 times x2 is c over a, right? Or x1 plus x2 is minus b over a. And we do that because this is what the quadratic equation solutions are. This is the formula for that. You add them up and you have it, la la la, right? That is not what we want to be teaching. It's not like that, right? Or the quadratic equation minima or maxima is x1 plus x2 over 2, right? Why is that a minimum? Is it a minima or maxima? Why is it? Is it just a rule? What does it hold? Why is it a minima versus maxima when a is greater or less than 0? What's happening, right? That's not our style of teaching. The whole thing that we try to do as a methodology, and I'm making classes such that this is the case, is to explain like why things are happening, right? So what does it mean, okay, if you have solutions x1 and x2? What does it mean given Bazou's theorem? What does it mean? How can we factor this equation? Okay, once we factor it, we have two ways to look at the equation. So that means this, that means that, right? It's trying to go behind the reasoning, or when you see a problem, it's not just saying, oh, the solution is you take, I don't know, like you do a certain coloring, right? It's a board and you do a certain coloring and you say, this is the solution. Boom. You just do this coloring. And the idea is like that doesn't really help you. Then it helps is say like, okay, what do you think of doing? And then getting some feedback from students. I mean, like, okay, what do you think? What would you do? Okay, here's some examples. What would you do now? And then going like, okay, so you've seen these examples, like small cases. Now, what ideas do you have? And then really going into what the motivation is behind anything, right? So what's the motivation behind coloring a board a certain way? Sometimes it's just, I tried a bunch of different things and this one worked. Sometimes it's like, okay, I have dominoes, so I'm going to do some like, there's going to be some parity things, so I might color squares alternatively. Or, you know, like there's a logic behind why things happen, and like our main method of teaching is what we really try to teach is how to think about problem solving, and so that you could then apply it to another problem. So it's not just you saying it's this formula, it's you going, oh, I need to do this because I tried this, and the reason I tried it is because I played with these small examples, or it was the third thing I tried. I mean, that's like the main thing, is like to have this sense of it's not going to be the first thing I try, but I mean this like tenacity, this resilience with the problems to like go ahead and try again, even if you at first don't have the idea. On top of what we're going to be doing is learning a bunch of different ideas. And this is the entrance to the building that I live in, and I'm going to give you a tour. So this is the Schwarzman courtyard. You can see it is a beautiful, so once you get to this place, the thing you love is just the architecture. Like, look at this. This is beautiful. Like, once you're here, it's even more beautiful. Like this thing, love it. This chair over here, absolutely amazing. This view from the chair, beautiful, even more so. Like this door, this lovely door. You see this door? You touch it. Oh, great. It's absolutely amazing. And then, one of the best things I saw when I came here, the wood. This thing, this is the wall. This is a painting. And this is the marble floor. It's beautiful. Like, this whole place is absolutely stunning. And yeah, this is like parts of Schwarzman. But if you want me, I could actually do a tour video at one point, because I know the tour of the building, having lived here for a long time. Now, when actually doing the edit of the video, I realized this was going very long. So what we'll do here is, here's the edit. And yeah, that's also the how we're trying to like make the 0 to IMO, the roadmap. So what we'll do here is say, okay, we'll stop here. And if at some point you guys would like me to do a tour, or maybe even talk to some other Schwarzman scholars, we'll do that. But for now, this is the life update. So went to Brown, finished Brown, started master's program, that turned into a PhD, and then had to leave the PhD so I could come here. Right before I left, like after I left, I started like the second iteration of of Chef Scholars, and then at Schwarzman in the Venture Creation Lab was building this up, which led to the third iteration of Chef Scholars. And now we are making the Chef Scholars Math School, right? Which is going to be the new project, super fun. Excited to see what you guys think of it. And as always, thanks for problem solving.